So, good afternoon, everyone. I welcome you all to this lecture, which is a collaborative effort by IEEE Young Professionals, Central Alberta section, and IEEE Site. So, last year we started our affinity group in the section which is called SITE, which stands for Special Interest Group on Humanitarian Technology. And we are aiming to come up with some projects which have some humanitarian impact. And in this direction, the young professionals community at University of Calgary, we gave a chance to three of the students from the department to go to Las Vegas early January this year, and they represented University of Calgary and Alberta region there. So during that time, they met Dr. Lu, and there was a collaboration which we were trying to set up between regions. Is it Region 6?
Region 6. Yeah.
Region 6, San Diego, and Southern Alberta region. So, in moving ahead in that direction, we were fortunate enough that he agreed to come here, and I think he arranged his travel by his own. It's a really big thing for us, and so it's good. Like things are coming up nicely, and we recently won the Best Young Professionals Award in the world. I must say. So let me introduce Dr. Lu. Dr. Zung Lu is a research staff member at Qualcomm's Incorporated Office of the Chief Scientist. Before joining Qualcomm, he was a researcher with Motorola Labs in Cognitive Sensing System Groups from 2006 to 2008. He conducts applied research in networking systems and application in the pervasive and ubiquitous computing and communication context. He has published several IEEE conferences, journals, and he has been chairing various different committees. He has different papers in the areas of wireless communication, mobile computing, graphical system, intelligent data management, and ubiquitous computing, which I think is a very varied field. He authored the pioneering book, Personal Augmented Computing Environment, which is used by several universities. Dr. Lu is also the inventor of 5 US patents pertaining to method for context-aware computing protocol and system for wireless display, intelligent activity interface of cell phone users, and NFC system for personal item tracking. He is a key contributor to multiple wireless standards spanning across WPN, WLAN, and WWAN. Dr. Lu holds a PhD in computer science from University of Illinois at Chicago. He is a senior member of IEEE and serves as IEEE San Diego chair and computer chapter chair. So let's welcome him, and we look forward to your talk.
Yeah, good afternoon, everyone. It is a great honor to be here. As Tusha introduced, that this January we had a Region 6 event in Vegas for young professionals and students. And it was a great pleasure meeting the IEEE volunteers from Calgary. And since then, we have been exchanging emails and talk about how to establish further collaborations. And this talk is the first step. And I do look forward to more collaboration between the two sections. And because I'm also taking some positions as a region, so hopefully, we can have a higher level of collaboration between Region 6 and Region 7 on certain topics as well. So I did notice that the southern Alberta section and the northern Alberta section, although it's just one word difference, but the northern Alberta section pretty much covers everything up to the Arctic. So that's an interesting fact to know. But this is my second time visiting IEEE Canada organization unit. My first visit was in 2009 to Vancouver. So it's great to come back again. So a little bit introduction about myself. I introduced my background. I graduated from University of Illinois Chicago campus, and I worked at Motorola briefly, mainly on mobile research. That's before iPhone was getting popular. And then after that, I joined Qualcomm. I worked at the Office of Chief Scientist for 6 years, and just last year, I actually joined the open source organization of Qualcomm Innovation Center. So the mission of this organization is mainly to create open source stack for wireless chips to be used that to benefit the whole ecosystem. I'm also lucky to be a volunteer for both IEEE Computer Society and ACM to deliver talks, and because mobile computing is a context aware, you name it, it's the right time for it. So I was really lucky that to be able to disseminate some of the knowledge to the best of my knowledge to IEEE members and ACM members. And just as the volunteers here, I served the local chapter and the section. Since 2008, I served from the computer chapter chair to the section vice chair, section chair, and now we have this structure called area in Region 6, because Region 6 is so big, so we divided into 5 areas. Basically, the southwest area covers San Diego, Arizona, part of Arizona, part of New Mexico, and so there are 7 sections. I'm also the vice chair for that area. And usually I give lectures in 3 to 4 hours format, do a very deep dive on a certain technology, mainly in wireless. But I look at my previous stack of materials and I feel the social computing, although it is not really something that I could earn a PhD with, but this is something that might interest people more, because I could be talking about EVDO, CDMA, how LTE, different specifications of LTE, but maybe that does not cater a wider audience. So I basically minted this material to talk about some of my observation and some of my understanding about social computing, and also bring to you some of the new developments that are notable in my understanding. So because of this, this is targeted at 1 hour 15 minutes talk, rather than a 3-hour deep dive of a certain topic. So it's different from my previous material for the distinguished learning tools. And also, I encourage you to, because this is my first visit to this section, and especially to the young professionals meeting. I'm not sure, if the content and messages are delivered to your best interest. So I encourage you to, let's make this an open talk, and if you have any questions, that you can raise your hand anytime, and we can backwards and we discuss about the number of you say. If you for certain technology mentioned in this talk, if you are of particular interest, because I'm not very sure about your background. I just arrived here 2 days ago. So let's make this deliver mass value of this. So the talk is organized as follows. I will first share with you my personal experience of a research project I conducted 2 years ago, and how that brought up my attention that the social factor could play an instrumental role in a lot of the research questions. Then I will talk about, because social computing, basically there's a wide range of definitions. I will talk about from my perspective, a professional who worked at a major mobile communication computing chip company, about my understanding of definition of social computing. And then I will talk about some of the enabling technologies, and why this social computing is as it now, and it also creates a better understanding of how social computing is going to evolve in the next few years. Because if we don't understand, the driving force of a certain phenomenon, then it's hard to predict how it is going to be in the next few years. Hopefully, this will shed some lights. And I will talk about some of the monetization applications that for both in the industry and also business-wise successful, and how which are social computing related. And then concludes and talk about my understanding of how social computing is going to be in a few years. Towards the last talk, I would like to talk about some of the eat your own dog food efforts that we are having in IEEE 6, actually also IEEE Global, that are trying to bring more social elements into IEEE daily activities. So, and we will open for questions and answers. So here's the real story. So about 8 years ago, I was just a normal, 9 years ago, I was just a normal PT graduate, just graduating and joined the industry. And that time, if I do exactly the same way that research was doing at school. So you basically do literature survey, and you build a prototype, and you simulate the results. If it's good, you believe that it will work perfectly in real life. So when this project was signed to me, it seems pretty straightforward at the beginning. So mobile ad hoc network research is a topic that's definitely not new. It has been there for almost 3 decades, I would say. So in 2013, I was undertaking a project that will say, okay, so smartphones is really carried by almost everyone. I think in the US we have almost 100 million or so 3G and 4G users. However, in rural areas, some Arizona desert, or in public safety situations, that you may lose access to base station power. And because we have these multiple videos on the device, can we create an more ad hoc network than CII? So this is if we write this as a PhD preliminary problem statement, the professor will shoot this down immediately because this sounds so simple. You will probably find 2,000-3,000 papers that on this concept, and that of course, I mean, there's a little bit new is you have coexistence of Bluetooth radio, you have Wi-Fi radio, and for Wi-Fi you have two modes. You have the so-called peer-to-peer Wi-Fi, that's Wi-Fi direct, and the normal Wi-Fi. But even for that, that's still not a hard problem to solve, I mean, at the initial side. So the idea for this prototype is we need to implement several features, including multi-hop routing, and I'm not sure how many of you are in the communication background. There are basically several well-established routing protocols that can help you do that. And the efficient broadcasting, multicasting, and when there are unreliable nodes, that this network, ad hoc networking system needs to be able to handle this in a graceful manner so that this will work. So this is really not a hard problem. I mean, why you can look at that. So I spent about 3-4 months and then built a prototype system, and then I used the off-the-shelf simulators in Kenya for sensor network research, and I simulated the results, and the results is perfect. If I publish it, let's forget about the novelty part, but the technical soundness part, if I publish anywhere, I think there's probably no reviewers who can attack me on that aspect. So I feel okay, that's good. So we built that into device, and then we have started a nice user trail, massive user trail, in number of near 1,000, and we put this in the field, and the results were awful. Was awful. Yeah, the service quality was very low. User experience is extremely bad. And think about this. This is even not a front user interface application. Right? All this built into network stack. Supposedly, I'm an engineer. I'm not an artist, but supposedly it should not affect me much. As long as you build this right, then it shouldn't be that bad. But the first week after we released this in the field, okay, I literally got hundreds of emails complaining about how could you release a product that's not ready. I said, no, I defend all those metrics, right? Effectiveness, efficiency, throughput, capacity, all this, whatever you need, whatever you And I did the simulation on all these aspects. How could I put it in the field and fail so miserably? So it took me a while to understand this because from the theoretical everything was okay. Actually, I actually have to look at a lot of data trace collected and then analyze it and think as well. And then I found out there was an important factor that was overlooked. That's the mobility pattern of people, which is drastically different from what's defined in literature for sensor network. So that's and because the mobile networking with smart devices is a relatively new thing, so that actually was not brought to my attention right in the literature. So that's basically this story. So let's go to the next page. And here, let me give you a little background. So in sensor network research, every node is assumed to be follow a cozy Brownian motion pattern. It's called the random waypoint. The random waypoint model assumes that a node will start moving towards a random direction for a random distance, and then stop for random duration, and then start again towards another random direction. And then it just repeats this over and over. That's how you do simulation in sensor network. Actually, after this, I started thinking about what kind of scenario is that sensor network. It's pretty much a bunch of some kind of enterprise spaceship, and lost control in outer space. So we start moving like this, right? But for almost 10 years, people have been using this, and people have been publishing papers, evaluating data sets, and this kind of golden standard.
So you mean to say academic research doesn't make practical sense, or what?
No. I meant to say because this social computing model was not there when people were doing sensor network research. So then this was not overlooked just by myself, right? It's pretty much overlooked by the whole community. That they just simplify this assumption. This is a golden standard to evaluate anyway. That's why I started this. So I ended up build our own simulator, and this simulator, if you look at the first version, it's really simple. So we want to fast forward it. So this is a very simple simulator. So this first simulates the random waypoint model, and this assumes that every user is following a random waypoint movement pattern. And from this, I conduct the network topology calculation, and then I will see how the network topology evolve. Along this time. So this is a visual representation, and this is basically the network topology graph that shows. So here shows the status of the nodes, and here shows the connectivity matrix. It's basically if the two nodes are within the range of short-range radio, which other than marked is as connected. As I use this, I use the shortest distance algorithm to calculate if I do multiple routing, what is the best way that I can reach any two nodes. And this one shows me the result. That it's very random, actually, if you look at this matrix. And sometimes between any two nodes, if you would like to bridge them, you could go as many as 7 hops. Obviously, based on random waypoint model, that if you are waiting between two routing algorithms, one performs better for longer hop or for larger hops. One performs better for shorter hops, and based on this result, you naturally say, okay, the longer hop one, that's the one that should be preferred, because in simulation, you actually see this network needs to handle the situation that there's often longer hops needed for routing. So this is using the random waypoint model. And then I built a more realistic model because we are looking at public safety, right? So this is the office model that the users will actually, their movements are constrained by office walls. Forget about the ugly animation, because like I said, I'm an engineer. I use the meeting tool to quickly do this, but the idea is first of all, the movement is confined by the building structure. And also, their movement is towards a clear destination. Right? When there is a public safety situation occur, so everybody will walk to the nearest evacuation point, guidance point. In California, that's basically the earthquake. In the Midwest, that's hurricane shelter. I'm not sure what are natural disasters here, but from this one you can see the pattern is just different. In a real public safety situation, first of all, people are moving towards a pretty fixed, predefined destination, and they basically work in groups. Second of all, there is segregation among groups. For the people in these cubicle areas, that they will move to the closest evacuation carrier point, and the people in this area will move here. So if I look at the routing matrix, basically I will not see very large number of hops. So when I choose the routing algorithm, I should basically choose something that works better for smaller number of hops. That's one. The second thing is I should not make the assumption that the whole graph is always connected. I should make the assumption that there will be multiple closely connected subgraphs. That's a more realistic assumption, and that's basically how social pattern is. So this shows, this actually, it masks out my bad artistic capability part, and it shows you more the mathematic part. So this shows what we call, this is for broadcasting simulation. And the thing that we have, I believe this is for the office setting. What is the name of the video?
Mobility pattern in office setting.
Yes. So here is the office setting. Again, this is mobility pattern I created that. So here we assume that there are multiple cubic spaces, and within these cubic spaces, people have different range of mobility. Right? For example, like a faculty member, here, maybe has a smaller mobility range, but the graduate students may be longer from here to there, going across laboratories. And so, but overall, all these nodes, they largely move just around their cubicle and neighboring cubicle. That's in the office setting. And this simulation, the background is, say, if I'm doing the broadcast algorithm, how the core backbone that should be constructed. The red nodes here are actually the core backbone nodes. These nodes are the only ones that relay broadcast message. Because if everybody is relay broadcast message, then there will be a flooding problem in the network. Right? So that's going to cause unnecessary network.
So this is what happens when they lose the track with the main base station, with the main base station.
Yes. Yeah. The application background is saying if we don't have cellular radio access.
So in that scenario, like the individual mobile phones will work as
At night.
Work like a kind of your short-range pager, lifesaver.
but in any case, they will have to communicate to the world outside.
Not necessarily. Maybe like in this case, you can share. For example, earthquake happened, and if some wall collapse, and really confined a certain area. But in this case, you need to communicate with each other and say, what should we do? And there are some trained CPR specialists, first aid, maybe it's the same here. Right? So some of you are actually volunteering as like first aid volunteers in a situation of a disaster, and you are supposed to calm people down and give people instructions of how to maintain safety and do some basic first aid.
But this mode assignment will be particular to every building. Like you cannot set a uniform.
Exactly. So, like I said, this research was really for people because without a deep understanding of the learning pattern, without a deep understanding of the particular area, it's very hard to design something that will work Canada, in the US, in India, and in some Italian small town, right? So this is difficult. So let me show you the next video. So this is office setting. And in office setting, let's forget about this matrix. It's very problem specific, right? My point is, if I change to another setting, this matrix will be drastically different. So let's switch to the next setting. So the next setting is that we simulate a theme park. In a theme park, you basically still have point of interest that's by this founded by these bounding boxes. But in the same park, people's mobility pattern is much different because everybody comes in from entry point, and they will eventually get out from exit point. And in between, it's a random order that is really different point of interest. So that's basically the same park pattern. In same park pattern, everyone will eventually visit every point of interest. While in the office pattern, there may be maybe your enemies and you never want to walk around him or her, right? So we don't know. But I would say also maybe not that. Maybe there are functional groups, right? So let's say people who do nanotechnology and people who do data mining. So their chance of chatting for 5 minutes in the break room is very low. Maybe it's right here, but in the same park, right? So it's quite different. So in the same park, if you do network research, that you will see your algorithms, and in this case, we are winning among several efficient broadcasting algorithms. So these ones will greatly affect. And as I said, this product is supposed to eventually pay for, but this one, but this one was a very good lesson learned by myself. That's for computing. If you don't think about the social aspect, especially for me, I'm both marketing and marketing in the mobile industry, right? So that actually adds a lot of challenges, which is also exciting, depends on how you look at that. So, but if you don't think about the social elements of the research problem, then you could be going towards the direction that's completely wrong, and you don't even realize it. Right? So that's my lesson learned. And after that, I start to read. I subscribe to Electric Spectrum, computer and it caught my eyes that there were some issues talking about. At that time, it's not called social computing; it's called societal technical problems. Right? So these problems are actually both related to social science and technical problems. So you need to understand on those sides. So I started reading that, and I gradually formed my own understanding of the social computing. I'm a computer science major. So from a computer science perspective, computing itself could be categorized as 3 elements. And you have something coming in, you process it, and you get some output. That's basically the elements of computing. So in the social computing part, any or all of these elements could have ingredients that socialize individuals. But these things that their behavior and their logic of doing things are determined by social behavior rather than finite state machine that is highly predictable. So this is basically my understanding. And if we categorize this, I mean, we can pretty much feel all these social computing tasks into the 3 elements. For example, social mobility and social media are basically mostly impacting the input side. And review and recommendation systems, collective wisdom, I'm on mechanical Turk. I'm on mechanical Turk is no longer active, but a couple years ago it was. Basically, the idea is there's a bunch of people who's helping you to do picture recognition tasks, and you pay them, and its result is actually better than the computer. And as output, so some of the computing output, for example, mobile apps, actually greatly affect people's social behavior. Agree? I cannot see many people look at this. Why teach at
It's sustained everywhere.
well, I teach at UCSD, I teach a class about this, and I always say, I say this is the index. Like, look at the phone index, how interesting it actually is.
Or then they might be just looking at the phone for the next information.
Yeah, but realistically, you and myself, so everybody is now kind of have this, syndrome that you feel that if you do not check your phone every 5-10 minutes, you're losing something important.
Yeah, like a girlfriend or something.
not from your professor, of course. But, right, you always want to be the first one to comment on your friend's wedding or Friday night party picture. You'll be the first one who liked it, right? And when you have something that you're so eager to share, say, oh, I'm in Vegas, and this my party is drunk. That's the yes, three guys, right? The other two is eager to be, oh, who's the first one to post this on Facebook? So yeah, this social behavior is actually impacted, but if we sit down and look at it from the technologist point of view, why people started to get addicted to this is because access to mobile apps and information has never been this easy. It's basically just a finger tap away. Like we say, in earlier age, when you need to choose between the Internet Explorer and the Internet Navigator, well, that's so ancient, right? We read it in historical books. You basically that's basically you need to go into a store and you need to buy the disc, right? If you need to try both apps, you need to buy 2 discs. You need to take time to install on your computer. But now these apps are side by side on your iPhone, just 1 millimeter away, or one centimeter away. So that caused no difference for you to type this or the other, right? So this kind of technology change actually it caused a great change in your social behavior. That's a couple years ago when Facebook was not yet mobile. Well, I need to do some Facebooking. I actually need, I need to. It's not pain. I need to take some effort. And now, if I have a picture, I could be accidentally sending this out. I didn't even notice that. That really shows how easy it is. And my social behavior greatly changed. So that's basically the social community. That's basically the background of this. And then let's look at so okay, so I mean not me, but myself earn a living by working at a mobile company, right? So I need to think about how this is work. And if I look think deeper on this, and we will see why, what kind of technology actually caused the social computing cannot be, is not negligible now. But because a couple years ago, we are perfectly fine. We don't think about the social aspects and everything was right. And why this has changed so much? And that's because of these following technologies. First of all, the mobile platforms really grow a lot. I mean, every of my paycheck come from the sales of Qualcomm chips, like Fortune. So I feel this in the most direct way. So in 2008, our processor that's running at 700 megahertz is considered advanced. And in 2008, 2007. And now we're looking at 2.5 gigahertz processor at its peak speed on your phone. So this is a drastic change with the same power consumption or even less. And because of this, computing is very much personal. Computing tasks is closely coupled to every aspect of your life. Right? I mean, in reality, your phone knows your mom and your girlfriend for work. So it knows much more about the dirty laundry and food laundry So that's basically the reality. And the reason is because a lot of your personal tasks cannot be performed. But think about what kind of tasks cannot be performed. It's called maybe because the productivity applications. Right? But with the new Wi-Fi, high Wi-Fi throughput that you can mirror your stuff on a bigger screen, you will soon see actually iOS is very happy. PowerPoint, presentation, spreadsheet, and WordPress into your life. So the boundary between productivity setting and a personal setting is getting blurred, and it will distinguish. It will disappear eventually. So that's why and the reason is because of the mobile computing platform. And the other thing is the wireless access technology. It may be used to either connect to other people or connect to the major computer resource in the environment. It's much, much easier now. So that's making computing ubiquitous. So there are two terms between, it's called ubiquitous and pervasive. I distinguish them by saying ubiquitous basically means you can compute everywhere, and pervasive basically says you can compute with anything. So that's my definition of this. I mean, sometimes people use it interchangeably. And the Internet of things are getting smarter in the environment. Right? I was running at the university fitness center, and I noticed that I can basically tweet on the treadmill. I almost tweeted like awesome here. You can tweet on the future. But so a treadmill that can tweet is something that's not very before.
Tweeting treadmill.
Yeah, tweeting treadmill. And but if you look at GoPro camera, right? GoPro camera basically uses Wi-Fi to link the camera with your device, and then you can stream stuff out almost in real time. And if you look at multiple wearables, and basically the Internet of Things, the intelligence built into the environment around us, these are also the reason. And of course, I mean, something that I understand, but it's not my domain. I listed them as enabling technologies by big data. And for big data, it's not a hype word, right? It's like in 2008, when I started to work at cloud computing was a hype word. When you look at hype word, you always need to say, forget about all the interpretations of other people, let me come up with my own understanding. So my understanding is big data is not only the volume is big, but the dimension is extremely big. Right? So before in the database area, when we need to characterize a student, you are probably 5-dimensional record. You have your student ID, you have your birth date, you have your gender, you have your major, and maybe something, right? Yeah. But now with the big data, for example, Facebook knows about all your activities since 2005. I mean, if you are signed up Facebook. So you could be a meaning dimension record in Facebook's big data repository. It knows every detail of you. Like April 1st, you did something really bad. Right, so this kind of thing. So
I know what it is.
and the power that ever cloud-based infrastructure that can quickly turn into information, into meaningful understanding of something to achieve a certain goal. So these are basically the enabling technologies. And I list the enabling technologies not because we want to understand, or first of all, we would have to understand the past. But we also would have to know, okay, how is it going to be in the next few years? Because these are the driving forces, and if we look at each one of them, we can have some idea of how it will be in the next few years. Right? So that's my motivation. Okay. So let's go to the next thing. So mobile platforms, I mean, needless to say, the volume really grew, right? And this is already historical. In 2007, smartphone shipments already surpassed the level at 2007, 8 years ago, even before I graduated. So, and of course, there are always some like fancy sentences that you can always you can go editor to impress people. Say, hey, you know, there are more people using mobile phone than people using toothbrush. and I know it always catch people. But this is a good one. And some statistics show there are 900 million smartphones used globally. I think maybe this number is underestimated. But anyway, these are huge numbers. So and these things, let's summarize the whole thing. I would say computing is universal. It's permanently universal. So that's a conclusion. And the wireless is everywhere. So these are the three pictures I take at different places. These two pictures actually I took at the San Jose self-serve laundromat. And I saw, most low-income people. This is a low-income area, and there, but it's Wi-Fi enabled, right? And I get in, and this look like drug dealers or everybody. They don't even bother looking at me. They are watching Facebook, Snapchat. So, but you see, this is something even at my age. I never see this kind of stuff. I don't expect to go to a gym that's treating. I don't expect to go to a laundromat. People don't talk to each other, but they're just do some kind of social activity, right? So, and I went to Beijing. There, I noticed that many buses now have Wi-Fi coverage, and but I don't know. Why do you build Wi-Fi on the bus? And you encourage people to start to have prescription glasses. I don't know, but anyway, so this wireless access is everywhere. So and this is undeniable fact, no matter how, but no matter why, but this is basically it is there. And if you ask me why, I would say okay because people are so eager to produce data, and because there are other people who's willing to accept data, so and this basically forces
But I think these things are also market driven. People want that laundry room should have a Wi-Fi access so that people start talking about that online, right? So somewhere it is creating a market value as well. So
Yeah, that's true. So that's okay. So let's do a little bit deep dive into some of the technologies. And the first thing is the Wi-Fi. There are two notable Wi-Fi networks. Basically, Wi-Fi is basically a big set of wireless protocols, all under the 802.11 umbrella. And there are two notable ones that is going to be impacting wireless access technology. And I will talk about them. The first one is the 11AC. 11AC is actually now fastly replacing 11N wireless network. And some of the background is this is a 5 gigahertz technology, so it's no longer in the cloud with 2.4 gigahertz spectrum. And this brings the gain of wider channel bandwidth. And it also uses more spatial streams. I'm not sure if this gives people background, but that's basically the spatial multiplex is you introduce the things Wi-Fi 11N, that you add a new dimension of multiplexing that you can use this and compared to 11N, 11AC basically double the number of spatial streams. And so let's forget all these detailed numbers, but 11N's peak data rate could achieve theoretically could achieve 107 gigabits. So 7 gigabits compared to 600 megabits for 11N, how it impacts the social behavior of the social applications is wireless video, even wireless high dimension video is going to be very practical. For Snapchat type of applications, you can expect it to be more in the proximity. That's real Snapchat. You can see through the wall and you see people just because the Wi-Fi gives you that bandwidth. And another thing is this Wi-Fi technology improvement also makes antenna design. That brings up something amplifier things here. And with similar antenna design hardware, that now you can achieve the same data bandwidth. Or if you would like to maintain the same complexity, then you can achieve higher data bandwidth. So this actually helps the mobile. Right? So that means this 11AC technology is really benefiting the mobile. And network capacity is improved by multi-user MIMO. So when I throw out these terms, I'm not seeing a lot of head nodes. So I would assume, I would presume that there's not many communication people here. If so, I will fast forward some of the technical details. But in summary, 11, let's in summary, let's put in the layman's words. The next, not the next, but the current mainstream Wi-Fi is going to make wireless radio widely available in your environment, and this is going to create a lot of new social behavior and social applications. That's basically the AC. And another interesting technology is called the 11AH. 11AH, let's put it in a simple way. This one is a Wi-Fi technology that works at up to 1 kilometer range. So, and this also works with this device that uses this Wi-Fi technology can last for a couple months with just a coin cell battery. And one access point could manage 1,000 of these devices. And what is this for? Internet of Things, right? So Internet of Things, the Wi-Fi will be used by Internet of Things as a wireless technology. Of course, the wireless technology is the low power Bluetooth. Yes.
It's already out.
Oh, the spec is we have prototype fields, but in the industry, every major player has prototype field. But the standard is supposed to get ratified next year.
Could you give us like what's the breakthrough that makes this possible?
Oh, what are the fundamentals that make this possible? Yeah, so there are several things. The first one is it works at a different spectrum. It works at in the US and Canada. It works in the 900 megahertz spectrum. So that basically gives you, and this is 900 is an unlicensed spectrum. That's how it is. So when you design the perk stack, that's because of less problems that you don't need to that complexity that reduces computing power. And the second thing is the channel bandwidth is significantly smaller than the other Wi-Fi technology. So, for example, the Wi-Fi 11N that make use of 20 and 40 megahertz channels, and this one the mandatory in the spec is just 1 and 2 megahertz. So it optionally supports up to 8 megahertz, actually 16 megahertz channel bandwidth if you really would like to burst it without transmit. But if you don't want to do that, then this bandwidth is very small. So make the compression that is much less in this one. And
you don't need to change any hardware.
no, you don't need to change hardware because this one
Just the spectrum routing in such a way that you're just routing a different spectrum to it, right?
no, not just that, but the modulation and the coding speed is also different. Yeah, it's also different. So the complexity is reduced by these aspects, and the transmission range is basically benefited by the spectrum itself. With the sub gigahertz, it's easier to make a longer transmission, a longer range radio than the other But did that answer the question? Yeah, okay. So notice this. But this is a Wi-Fi technology, interoperable with your Wi-Fi devices. That means 1 kilometer, what is that range? That's pretty much if you stand at the center of your campus, that covers every building. If we don't consider the pass loss, if you consider in the open field, football field, then that means this covers pretty much everything in the same football field. And let's assume the football field under every seat there is a sensor. That means that with a couple sensor bridge, a couple access points bridged together with your phone, you can pretty much browse the sensor information come from the whole stadium. And because each access point you manage 1,000 sensor nodes. And if we say there are, let's say, 12,000 sensor nodes in the UOC stadium, it's going to be more. I don't know, I just need to come around. But with some access points, with just 12 access points with each other, then you can use your phone to browse any sensor data under each stick. And this opens huge opportunities for new social computing applications, and this will also affect the people's way of doing a lot of computing tasks. So that's the 11H. And this is coming, personally, I think this is going to be very popular by 2018. Because the reason is because the interoperability among with other Wi-Fi devices. You don't need to, so the answer for your earlier question is, for the AH device, yes, you need to build a new stack and new hardware. But for the device that interoperates with AH device, and you don't need to make anything. Because at the Wi-Fi layer, everything is interoperable. So that's the AH technology, and that's the next page. And of course, a lot of people started using Fitbits, right, all this kind of wearable technology, and most of them are using Bluetooth Low Energy. Actually, in 2007, I was part of the Bluetooth Low Energy. At that time, it's called, Jesus, it's so many years ago, I forgot. Oh, it's called Bluetooth Ultra Low Power at that time. But this is a technology that allows Bluetooth devices to run on coin cell battery for years. So, and this one basically enables a lot of wearable devices, and this device is basically called Snap and Fan. That's basically an active tracking device. How many of you are using Fitbit or Fitbit-like trackers? This watch. Yeah.
It's like the small watch that you get in how many
Yeah.
My friend has it, I don't have it.
Okay.
No, you don't need to have it. But you can install it the app, right? Now
Yeah.
people are installing app.
Yeah.
Phone sensor.
Yeah, phone sensor it consumes more power, but I think for Fitbit, the thing is, Fitbit, the cost is still a bit high. That's why the penetration is not high. In California, you always see the fancy stuff coming first, right? Even before they are in market, you see some very weird stuff. You say, what is this? Oh, I can tell you, but I have to kill you. This is some $1 billion startup. So I start to see a lot of, and the cost of this is dragging down by Chinese manufacturers. You heard about the Xiaomi?
Yeah.
So they are making $15 wristbands. That's comparable functionality. I'm pretty sure you will soon see it. So anyway, but we talk about technology, right? So wearable, wireless is making wearable, very practical and very social. And I was actually on some fitness app that can link to your phone or this fitness device. Earlier, I have just 10-15 friends signed up this. So if I do some work, moderate amount of workout, I can always get into the middle range. And now, so many of my friends are using these wearable trackers. I often find if I don't exercise, I'm falling out of the first 100 spots in my friends.
They also give you bonus points and give, like if you have like 10,000 steps, they give you a gift.
Yeah.
Milestone gold medal something.
Yes. So and that gives me huge incentive for me to exercise or this kind of thing. That gives me huge change.
Now people will exercise because of those things, not
But that
because
is
they
not
want to
gold
keep
medal. That
them.
is not actually gold medal.
Yes. So this is the Bluetooth technology that's changing this. So let's go to the next page. And for the cellular technology, the 4G has been already rolled out all over North America. And basically, the LTE technology can now offer you up to 500 megabits downlink data rate. That makes video available if you can afford that. And 100 megabits uplink data rate. This causes more people to Snapchat. And sometimes you see the term that's the category 6, category 10. So these are basically say the phone is capable of doing how advanced the LTE technology is. That put it in a simple way, the higher number that is, that means your phone could do higher data. So this is basically the LTE. And in next year or so, another LTE technology is going to hit. you will start to see a lot of change in your friends and yourself's behavior soon. That's called LTE direct. That's a device-to-device kind of thing. So that means a lot of the information now you can share peer-to-peer with LTE devices in your range. If you, let's forget about the security and authentication part. But the technology-wise, they allow you to do this directly. And it will allow you to do scan. If I would like to do scan for IEEE members across the campus, I don't need to log into our central IEEE server. I just do LTE scan. And this LTE scan works in the 500 meter range. And if people say, I'm actually a member and I would like to indicate this on my phone, and they will show up in your radar. And you are basically like a high warrior. Right? So,
Nice.
you see this manual. This benefits your site and non-professional activity for sure. So, but this wireless technology, let's do a quick review. AC is already there. It's changing your behavior gradually. You don't notice that. But AH and LTE Direct, these ones are going to be there next year or the year after next, and you will see a lot of things coming up on this. If you start to see a new startup doing some kind of social application, that don't feel very surprised because you might remember in a very nice way after listen to a talk, and there was this technology is done there. So that's basically so AH and LTE direct get into this tool. So let's look at the monetizing application.
Alibaba.
So Alibaba, of course, that's a huge that creates a big news space. But if we do look at the bigger picture, bigger picture is in the past 5 years, all the major IPOs are in companies that we call internet companies. But the new area internet company is different from the old area internet company, like Google. This new area internet company all deal with your personal stuff. Right? So if you look at all these companies, LinkedIn, right, captures all your professional contacts, Facebook, your personal friends. I'm listing both US and China companies. Chinese companies are being listed in NASDAQ or New York Exchange. And 58.com is basically a crapless type of website. In China, Twitter and Weibo are both alike. Weibo is basically the Chinese type of Twitter. And JD.com is a direct sale company, much like Amazon. And Alibaba is very interesting. Alibaba is, everyone will say, what is Alibaba? Right? Alibaba say, oh, we are not, we are the world. So they say, we are the ecosystem. But Alibaba, in fact, is, I would say, it's a virtual government or virtual, it started as an escrow service. Because in big population countries like China and India, the problem is people spend cash and there's no credit system established. So Alibaba started as a virtual, I put it in the government way, it's not politicalized. Because it maintains a credibility and your record of you, and it manages and regulates your behavior using this kind of data. For example, if you're doing that in a certain transaction, then this one will be captured by Alibaba and it will affect your image and your credibility in this virtual world. So they started as an escrow service, and this builds this, and that's why people always hard to compare Alibaba with a counterpart in the US. Is Alibaba really eBay, or it's Amazon, or it's a virtual bank, right? So, but it's basically that kind of thing. And there's a social networking service. It's called Momo in China. It's a very interesting Chinese-only social application. It's very much like identity. It's a proximity-based friend finding service. People would say it's a flirting service. But if you add them up, the market cap is just daunting. Still less than Apple, but Apple is an outlier. let's forget about Apple. But this internet company has a huge market cap. And in just 5 years, past 5 years, the economy is putting that much of money from investors' pocket into the so-called people-centric or social behavior-centric economy, and that's basically, that has two effects. The first one, it caters the growth of the technology, right? Technology growth and economic growth. The second one, it's fostering a lot of innovation. Again, when I'm teaching at UCSD, why there are so many people doing, looking at their phones? I mean, they are looking at business proposals. Actually, 3 of my students last year, they started their own 3D printing company. It's quite successful. They keep me on. But I would say, this kind of new economic model, of course, 3D printing is not related to serial computing. But the serial computing model is getting a lot of quantum computing. It's growing at unprecedented rates. So this is basically this. And let's look at some of the social behavior that's changed by technology. November 11th, because all the numbers are 1, so it was fabricated as a holiday. Not a holiday, shopping spree day. In China, it's called Singles Day. And in 2014, this Singles Day started in 2009. And look at the sales volume is very much before. It's like Target before Target ended its Canadian market, right? However, in just 5 years' time, it sold $9.2 billion worth of goods in 2014 on the same day. And in 2014, Alibaba took Alibaba 43 minutes to sell the whole volume of Cyber Monday. I think the Boxing Day here, right? So maybe once a quarter, one fixed size of Cyber Monday. So I would say in less than an hour. So Alibaba sold the whole merchandise volume than North America combined in the holiday shopping. And this one is actually really fostered by technology. If you think about it, without this high penetration of mobile devices, without the high trustworthy transaction systems, without reliable big data to analyze how do I precisely target the advertisement, this one we don't have. So this is basically a two-way thing between technology and social. So that's why it's a social technology problem. I think that's a very precise. So that's one. And I noticed in China, because of the e-commerce explosion growth, a side industry in China actually grew also significantly. That's the delivery business. So these are the pictures I took at the Common Chinese University with a student body size about the same size. And because everybody buys stuff online, and these packages were basically delivered to student dorms, that creates a huge bazaar type of space. And this is just a single, this is not even a single day. This is not a cyber Boxing Day type of day. This is a normal, boring. You don't get extra money from the parents' day. That you see piles of goods delivered to the university to students, and this was not seen 5 years ago. So And if I look at the numbers, the delivery personnel workforce in 2014 reached 3 million. This is a business sector that grows 6 times in 5 years. And by any standard, this is very significant. This is a business sector that's completely self-contained by itself. So, and if I look at these youngsters, I bet their behavior is much different from their seniors 5 years ago. So let's go to the next page. So Abawada is the famous Indian lunch delivery system, right? So, and I read this only, I read articles about Harvard Business Review saying how effective this thing is business learning material. However, in just last year, not even 5 years ago, just last year, there are three Chinese internet giants that start to launch their own Padawana type of service, and then it reached a huge scale. So what's the scale? Let's look at the number. One of the player is called Ele. This player itself achieved 110 million deliveries in 2014. And before 2014, this business is very negligible there. Very negligible there. So these three players, they can succeed mostly by several things. One is the capital funds. So last year alone, there's over $10 billion pumped in by investors into this business.
And this is only in major cities, or is like
It's just in China.
This is
110 million, I think.
only Beijing or main cities or throughout China?
not just the main city, but it covers about 500 cities.
And so the population will be even
Population covered, yeah, it's about, I think it's about 200 to 300 million.
So they have like almost targeted.
And this
Yeah.
is only about to increase. This will only improve because like population still might use this.
Yeah. But the thing is, before 2014, this is not before 2009. Before 2014, people don't even have the habit. I mean, it's not a common habit for people to order catering food, right? And of course, the shipping industry greatly helps this, and this Chinese Dabawalas. Chinese Dabawalas, I call them Chinese Dabawalas because when they go to China, they're using exactly the same equipment. They're using bicycles with racks to carry food, and they're using this very rudimentary the temperature keeping equipment, but it's very effective. And for every delivery they do, they earn about a quarter US. Right? However, the venture capital is really pumping money into this, and it makes this it fundamentally changes people's behavior of buying. So this is very impressive. So that means people are changeable. People are changeable. I learned this in 2011 when I visited Singapore. And because every Singaporean tell me, people are changeable. We are a society of social engineering. If you make a rule, people will just behave like that. And I say, oh, this is Singapore only. But then I find out, no, it's not. With proper technology catalyst and proper social incentive, and people's behavior drastically change. And
Like Steve Jobs said, I will tell you what you need. Like this
Yeah.
and just telling people what you need. Like people were still eating in China before the law, right? But now they are.
yes,
They can also eat
but
this.
they are more likely in this way. So let's go to the next page. Are we getting over time?
No, it's fine.
Oh, okay.
We are just. It's fine.
So Uber's valuation recently grew drastically because it comes to Chinese market. China market. But this is very interesting because Uber is the number 3 to enter China market, and there were already 2 players almost dominating Chinese market. Right? The two cab services. One is called Kuaidi Cab and one is called the Didi Cab. In the past 2 years, using huge economic incentives, they are basically giving rebates to people who use this app to do cab.
Yeah, they get like $25 free if you
Yeah.
install their app.
Yes. Yeah. So they put in total about $500 million, right, just to give people incentives to do this. So in 2013 and 2014 timeframe, these two companies actually fight with each other in a bloody war. That eventually they cannot sustain each other. They cannot burn money in one way, and they merge. Right? They merge last year and become they become the huge giant in China, controls 80% of the market. But interestingly, Chinese were educated that they can do cab service in the Uber way. This is very interesting. Uber, actually, if you look at the Uber valuation last year was about 15, 20 billion. And this year, there's reports saying it could be worth 50 billion. And because Uber, I don't know how Uber is successful in India, but Uber is already set a foot in China as number 3, and it's growing very fast. And I would say Uber really should, pay big bucks to its competitors in China, because without this company, with these people changing social behavior of Chinese people, doing app call for cabs, Uber will be paying that price, like copying that. So this is very interesting, very interesting. Actually, interesting is I was taking cab in Beijing, and I talked to the cab driver, and the cab driver educated me almost 20 minutes about how these companies are using different ways to incentivize. For example, if you have a hire that's a shorter distance, that you tend to take another hire that's a longer distance. A cab driver can actually pick up a big dollar amount job. So the way is this system will automatically calculates the price difference between these two and give you an incentive of the price gap difference. So to make you less, make that not a factor for you. Things like that. The character talk to me almost 25 minutes all about this algorithm. I say, except for using the term algorithm, you are telling me exactly how the algorithm works for the back end. And that's for my normal character. Right? So my wife is an economist. So these years we find more and more we have words in common. That I started to read the Economist magazine, and she started to read the computer magazine. Because very much we found the articles, it's more and more easier for each other to understand. Actually, next January, I will employ her for the communications magazine, for social computing communications. So if you are in communications major, and if you're interested in contributing to this special issue, just keep posting. We are going to issue the global papers. So conclusions. So we don't use the hype word. We say, the future is social. The present day is social. We are living in a social No matter you are doing communications, or you're doing computing as a research project, or think about your future career, think about knowing more about social elements, and do some interdisciplinary reading is going to be not beneficial but mandatory to understand some of the fundamental research problems. And you need to think about the business models not only are duplicated from real world to cyber world, but there are also some cyber world only business models. For example, this LTE proximity scan type of application. This one's really easy. And the industry and business growth is going to be at an unprecedented pace. Already have been in the past couple of years, and will be in the next few years. So that's why when you actually really news about Uber and Airbnb, I think Uber being an extreme case, because Uber's valuation really skyrocketed. And people were saying, hey, why? This is the best call service. Why? But you need to understand some of the big things. For example, why the Chinese market is becoming, could be a potential cash cow for Uber. So you should understand from the background. So that's basically concludes the social computing part. And let's talk about the IEEE. So actually, I'm not sure if you noticed or not, IEEE started to do some of the applications that's trying to have social elements. And the first one is called the IEEE ConnectTech. IEEE ConnectTech is IEEE version of Facebook. So I think it's IEEE. If you Google IEEE ConnectTech, you find this. And with your IEEE user ID, you can sign in.
And even I think the non-IEEE members, they can create account on it.
Yeah, they can create.
You don't need to be IEEE member to use this application.
Yes. So the good thing is now you can virtually link with some professional in Silicon Valley, for example, which I was talking about. From Calgary, how do you find the next career? If you like to Silicon Valley, start in this way, right? So go to the IEEE ConnectTech, search for Silicon Valley, you find a lot of IEEE members there. just friends and include them. And this is and actually CloudTech is penetration rate is growing very fast. Yeah. It's growing very fast. With this, I was able to connect with some of my old friends in Colombia, in South America. Before I meet them every year or so, but now it's much easier for us to talk about attribute business. So this is attribute CloudTech. And the other effort, the next page. The other effort is the recorded meeting initiative. In Unit 6, we are starting to record meetings and encourage organizational units to record their meetings and submit to this system. So I'm actually in charge of this project, and this one has already attracted over 70 videos from Region 4, that's the Midwest United States, and Region 6, that's Western United States. And this number is still growing. And San Diego site is basically spearheading this effort. But we welcome anyone who's interested in, contributing to this. Actually, this is one thing that I think our two sites can collaborate with each other. Yeah. So this is an open source project. It will be open source. So that also gives you, if you are interested, you should add an extra point to your resume for some work development. This is also a good project. So another project also actually San Diego site is leading and sponsored by IEEE 6 is a context-aware app that allow you to find nearby IEEE organizational units, meetings, and also the volunteers. So in this screenshot, you can see if you are going to San Diego, then you can actually see the 4 student branches in San Diego, and you will see the meetings nearby, and you will also be able to link with the volunteers locally. And we expect with more peer-to-peer technology that this app will be useful. It will greatly help you to collaborate with attribute managers in other areas. So this one is also an open source project, and if you're interested in app development, that's I encourage you to join us. This is fun. And here's another project. This is a bigger attribute initiative that by SUPSI in Switzerland, San Diego site, Shanghai section, and Colombia site, that we are trying to build a platform called Virtual Volunteers. The idea is, this is a database that if you sign up as a volunteer, it will collect traces of certain activity in a privacy preserved way, and then store as a central database. And then it will be, everything will be anonymized. And this data set is supposed to generate a trace that for entrepreneurs or students who would like to find new opportunities for business, that they can use this standard data set to test their app. For example, if you have an app, you say, I'm going to do not a CapCo, but a book, use the book exchange in a peer-to-peer fashion, right? Instead of having a central marketplace and everybody selling a book. I say, okay, just bring your book with you, and one person will walking, helping someone who is interested in it. I'm completely making this up. But the thing is, for entrepreneurs or for students who would like to innovate, this is a huge trial and error process. You can just make a very blind guess. Not far from looking at the crystal ball. So by using this, we plan to collect traces in several cultures. If you look at this one, it covers Europe, California, it covers China,
South
users, and also South America. So we plan to collect about over 2,000 user data traces by end of 2016. So this is all these projects are actually funded with different funding sources, and we are actively looking for volunteers to join us and fund. So these are the things that's from attributes. So this really concludes my talk, and this is my email, and if you have any questions, please send me to me, and I'm welcome any questions.
So, any questions?
Just a couple of questions. One relates to the local ad hoc networking that you had done your file on. That all has to go through standard frequency bands, right?
Yes,
But you can operate independent of the main
infrastructure.
transmission line of the signals, because if they were down due to an emergency, you can do it locally.
Yeah.
So that means you've got to be able to switch back and forth pretty quick depending on where an individual is and whether or not they can see
Yes.
main signal.
Yeah. So there is a thing called the connectivity engine that constantly monitors the connectivity options. And for example, if the Wi-Fi is bad or cellular is bad, then this connectivity engine is going to switch this connectivity node back to that. So there is an engine. So I'm presenting a simplified version of that.
Is it, when you mentioned that, it made me think of the inverse problem. What if you want to run a network and using radio powered devices instead of, again, with the cell phone, but you don't want to be using the backbone infrastructure of the main bandwidths that are allocated already? I guess you'd have to dodge the bullet try to do that. And it's just sort of like, in some communications areas, it'd be great if you get a huge amount of additional bandwidth.
Yes.
And the most extreme example I had of that was Greg Bailey of Nickel Mining Company, Inco in Sudbury. And he said, here's our communications bandwidth that we can use. He said, you see that band there? That's the emergency signal band.
Oh, okay.
Because the rest of the bandwidth in an underground mine doesn't count. They can use the whole thing.
Yes.
Nobody can use that except that.
So there is a whole field called opportunistic networking. That's why actually some of the researchers are looking at things. For example, this licensed band, when they are not used, how can you do opportunistic transmission without impacting? Because these ones have very high quality of service, stringent quality of service requirement. So without impacting how can you make opportunistic? Yeah, there are researchers.
So who's using that besides maybe some security police guys?
Oh, who's using that? Everything so far is in academia. It's not the industry. This is the hard problem because unfortunately we need to find regulation and monetization. So, but this I mean in academia this is a perfect research topic because the fewer people are looking at that, the higher chance you publish a book. Right? So this is I see quite a few optimistic wireless communication paper that's trying to penetrate this.
If somebody else I've got another problem. We were trying to promote conferences using social media. It's the first time, and there were younger PhD candidates on the team, so they knew what they were doing, and I really didn't. But it's a real challenge trying to use.
Yes.
It's a lot of work to use social media, and then you find yourself looking under every rock and behind every tree and hiding under blankets and all that. And you end up with a whole pile of different sources of information that are all over the place. And it makes it 10 times more work to actually put material up the channels and then to follow up.
Yeah, so my take is, I think you're going to the topic of this talk, but my take as an actual volunteer using social media is social media itself is a means of doing things, but the key part is you need to incentivize people. For example, if you say, okay, we are giving out a raffle draw of free football ticket, then it will immediately create some effect of attracting people. And if you have some people who's kind of like a campus celebrity that help you to disseminate this message, it has a much higher chance of getting people's attention. So this is actually the perfect example of social technical behavior. It's not like technologically you can reach everyone, then you can get the outcome. But if you have some social elements with the same technology, you can get an outcome.
And I think like this is even adding more to market, and many companies are now coming up with the like they sell you the packages. Like for example, if you are organizing a conference, they will take care of for all social media. In the end, they will give you a data analysis. So many data analysis companies are coming up with social media packages. So
Yeah.
a huge chunk of money is going that side, and they are and IEEE itself outsourced, like IEEE Communication Society outsourced all social media work to a company named Real Man. So they pay a huge amount of money to them just to manage the data. So that's the other side, right?
Yeah, we were getting that just because a lot of the professors and students have access to that, to the Google Analytics and the rest of the stuff.
Yeah.
But the one thing that, and it really helped, because I'm more from the traditional side of just bombing everybody with mass emails for the conference. And, magazine, journal ads don't sound like much, and they probably don't have much impact on the current publicity.
Yeah.
But I think they're a lot more important than people think in terms of the long-term status and image of a conference. Like, if you're the only conference that gets put on the back cover of 2 or 3 of the major journals, at least you've got that. It's like people can point to that as something.
Yeah, these are just add-ons. Like if you are already doing it, then social media is.
It's just, we're doing it, but at the end of the day, there's in San Francisco, there's a big data conference, International Neural Network Society. That was one of the conferences. And there's a deep learning neural networks workshop. And we were getting huge hits for us, anyways, on the deep learning workshop. But then, if you're responsible for some of the publicity, the general chairs hit you over the head. Where are the, where are the people that are signed up for the thing? We still got another 2 months for that. But how do you translate some of the obvious interests into actions to buy into it? I think that's the same thing in advertising everywhere, right? The social media is a little bit more slippery on that.
Yes.
Okay.
Yeah. Oh, yeah.
And if there any research was breakthrough in this area because you can have multiple lot more.
Yes, I'm glad you brought this up. 60 gigahertz technology, for example, 1180. 1180 is a 60 gigahertz technology. 60 gigahertz technology, in my personal opinion, first of all, as a major Wi-Fi industry player, I'm taking the path research and also to standards presentation for 60 gigahertz technology. So here's my personal take for 60 hertz technology. First of all, it's a line of sight technology. So that means this is, and it's also a relatively shorter range technology. So that means this is mainly for in-home use. In-home use. In-home use, for example, connect your Blu-ray player to TV screen, or share peer-to-peer with picture on the phone. Right? So that's the use case of this. So the other thing is interoperability. So Wi-Fi is not the most ideal technology initially, but Wi-Fi 1 is grounds by there are so many devices using that, and they are interoperable with each other. So that's why if you look at the AH technology, that's actually head-to-head competing with technology like Zigbee or some kind of Bluetooth. But I'm pretty sure that one, the AH technology and other Wi-Fi licenses, for example, the AX technology that is looking at a couple times higher bandwidth than AC. But that's 5 years later. But I think that's why we propose that if not replacing 60 gigahertz, we propose a very strong, very strong product for 60 gigahertz because it interoperates with other Wi-Fi devices, and that's very important. When the market is already used by Wi-Fi or any other technology to get a big penetration. It's very difficult.
So it's more like I just want to add one thing. Like I was in an international microwave symposium last week. So people are coming up with the chips like which will be pasted on your skin as tattoos. So the thing is that you can control anything in your room. Like if I want to switch off the screen, so that chip if, will have like my hand gesture. If I do like this, the screen switch off. If I do like this, the screen turns on. And most of their like all that application is at higher frequencies, like at 30 gig or and they are pasting the chips over here or like body. And if you want to see okay how my skin is reacting to particular environment or particular weather, so they can analyze and then they can predict that okay in this much time these many pimples can come on your skin, so start doing this thing. So there is whole range of things which are going on, and it's leading towards wearable technology, that they want to wear the technology on their skin and on their body.
A longer range or
Longer range,
non-line of
60.
sight thing. Yeah, there's some not breakthrough. There's some progress on that, but not yet significant changes from the
For 5G applications, like many people, like I was reading a paper, what will be next 5G, and people are talking about waveform engineering in the sense that like OFDM is the main, is the major useful sort of waveform that we use. And people are talking about other waveforms that are like non-orthogonal waveform shaping. What is your take on that? Like, do you think that for like, OFDM will be like, these techniques that will exist, the modulation schemes that we still use, will be the thing of the future also, or will waveform engineering will take a new sort of a direction?
Yeah, there are several modulation scheme candidates that are currently competing for 5G candidates. So that's for sure. OFDM being one, and there are others. So that's the other thing is 5G technology is basically more throughput device is more talk about the network capacity rather than the data bit between any two devices. So this 5G, if you look at the 10 gigabits data rate, that's more like overall network capacity. A good analogy is if you look at AC data. AC have multi-user memory. So AC is 7 gigahertz, 7 gigabits data rate is achieved, say, from the access point. That overall throughput from the access point to multiple devices aggregate could be 7 gigabits. Because if you would like to have a 7 gigabit throughput on one device, that device needs to have 8 to 10 antennas. Yeah, so that device is going to be a bulky device. Actually, for some of the AC devices that you see in the market, they're already very big. There's home routers like this size. So 5G technology is going to be the same. If we expect the phone will be, our phone will be have 10 gigabits throughput with the same power, even in 5 years, I don't think that's going to happen. What's going to happen is, from different layers of the network, there's going to be a lot of change. For example, application layer application, network layer application. And with your multi-user nature, that you will be able to get this equivalent effect of getting 10 gigabits worth of data on your phone, but not necessarily from one device. And 5G itself is still a challenge.
Yeah.
So that's why people set a goal, so we're going to do 5G. But how do we go to 5G? Yeah, I think, but as the physical layer, coding scheme, modulation scheme, all the things that people still looking at, can we have some breakthrough? Or can we have modern technologies, if not replacing each other, it's complementing each other? So this one actually
This is a very good question because when even academia people work a lot on OFDM, so certainly if you know that there's
yes,
things,
yeah.
you know, things.
Yes. No, I don't think OFDM will be. I think, like I said, it's most likely OFDM will be replaced. it could be complemented, but to which extent we will of actually that. So that's my
Okay.
any
So
further question?
now
Okay.
we have a small. Shall I stop it?
Yeah.